Brief summary. We're constructing an unscaled graph of the tangent function. Tangent function is the sine function divided by the cosine function, meaning for any position along the horizontal axis here, the value of the tangent function is the value of the cosine function divided, the value of the sine function divided by the value of the cosine function. I will point out that these 2 points, the two graphs, and of course I've got the graph of the sine and the cosine function. We already know how those are done, so it's not really necessary for me to point that out, but there it is. The point where these things, where the two graphs cross, should correspond to the midpoint of the interval that represents the first quadrant on the reference circle. And you should understand why that is in terms of the reference circle. It's not the case here. They intersect at a point that's pretty much corresponds to this horizontal position on the horizontal axis. Okay, and this position is a little more than halfway between here and here. So I didn't draw the graphs quite right. They're a little too fat or something. Over here, they intersect about where they should. This point appears to be about halfway between here and here. Here, I got the shape just a little bit wrong. Okay, well, that's kind of a minor point, but you do want to understand that about the graph. Okay, we want to construct sine function, value of the sine function divided by the value of the cosine function. First thing we do is we pick a unit. Now, a really convenient thing to do is pick a unit that's equal to the distance of a maximum or minimum value of the function relative to the axis. Okay, and I chose not to do that just for generality. This is a little too big. Okay, it looks like the unit is about up here. And there's nothing wrong with that because these are unscaled. Everything is unscaled. I can pick any segment I want and say that that segment has length 1, and I will get an unscaled graph of the tangent function if I proceed to do all my constructions correctly, okay, and accurately. Now, I want sine over cosine. Well, that means I want the sine multiplied by the reciprocal of the cosine. And what I'm going to show you, incidentally, is not the most efficient way to do this. Okay, it's absolutely not the most efficient way, but it is one way, and you should understand how it works. And then I'm going to ask you to, I'm going to suggest that you should actually construct this, at least for 8 points between here and here. You should actually do these constructions. That's tedious enough that you're going to want to find a shortcut, and you're going to start thinking about how you could do it with fewer operations. Okay. So we construct the reciprocal of the cosine. To do that, we first take the value of the cosine, which corresponds to this distance here from the horizontal axis up to the blue line, and we construct a segment of that length. That's the yellow segment here. Then we construct our unit segment. Take this unit segment, construct it here at a right angle. Then we anticipate what's going to happen, and we not only draw the hypotenuse, we extend it so that everything is nice and straight. And I didn't really succeed in the nice and straight part. So, but if you use a straight edge, it's a good idea to just go ahead and extend this if you see that you're going to have to do so. Now, why do we have to extend this? It's because, well, first of all, here's the value of the cosine, and here's 1. To get the reciprocal of the cosine, and we've done several reciprocal constructions, so you should know what's coming. To get the reciprocal of the cosine, we're going to have to extend this side till its length is 1. So right there it is, in purple, kind of right over the yellow, and I've labeled the length 1, and that's this side. And it follows just by the similarity of the triangles that this side has length reciprocal of the cosine, relative to this choice of unit. Whatever the choice of unit is, we're going to get a consistent result when we complete everything. Then we want to multiply the sine by the reciprocal of the cosine. Now, I asked you to think through how to do that before I showed you this. This is not the most efficient way to even do this once you have this value, but this is the way we're going to do it, okay, because I want you to discover more efficient ways to do things. So here's the value of the cosine. Now construct a green segment that has that same length. Okay, there's the reciprocal of the cosine. Then, perpendicular to that, I construct a side of length 1. Now, all I then have to do is take the value of the sine, which is this, construct a segment of that length here, and then construct a line parallel to the hypotenuse. And the length of this side is going to be the sine over the cosine, which is equal to the value of the tangent. So we get this value, and there it is. And we then locate our point on the graph accordingly. Now, we do this for every point of the graph. Of course, we can't because there are infinitely many points, but we do it for a representative sample. And the whole idea is that since we can construct a dense set of points on the graph of the sine function and then complete that so that the sine function is defined for every real number, we can construct a dense set of points for the cosine function. Every time we get a point on the sine graph, let's just shift that point over here and mark that as a cosine. So we have a simultaneous construction of the cosine graph, if you like. Then everything we've done here is doable by compass and straight edge. So we can take any number of points along the horizontal axis, whatever we have time for, and do the construction and get the value of the tangent function, the sine divided by the cosine. Okay, we're going to go on and see what the implications are.